Hello, everyone, and welcome to exam prep discussion number 7, walkthrough of question 4b. So in this question, we are wanting to come up with a program that, given a number, will swap bits A and B, where A and B are indices that are 1 indexed. So it's just to look at a toy example. If we have the following number 1101001, swap on 1 and 5, we'll take bits 1 here and 1, 2, 3, 4, 5. And it will swap them. Okay, so the 1 and 0 traded places. So we're just swapping the bits there. Okay. So we need to come up with an algorithm for doing this, and it might be best to try and, as with bits tend to work maybe in the most intuitive way for us initially. So we want to maybe it's best to try and break this down to 2 cases. The first case is when the bits are different in the 2 locations, so we actually have some real work to do. And the second case is when the bits are the same. So, and if the bits are the same, then we don't need to do any work. Okay. Let's consider the first case first, because this seems like the non-trivial case in a way, because if there's actually work we have to do, we can't just return the number immediately. So let's go ahead and take a look at that. Okay. So in this case, right, when the bits are different, one observation we can make is that we basically need to flip the bits that are there, right? So this 0 needs to get flipped and become a 1, and this 1 needs to become flipped and become a 0. So we might recall that the XOR operator is very good for shifting bits, right? If I XOR a number with 1, it gets flipped. So if I go 0 XOR 1, it becomes 1, and if I go 1 XOR 1, it becomes 0. So that's really great. We could try that, right? We could basically put 1s in the corresponding indices and then XOR them, and we'll find that that actually works, right? That this 0 became a 1 and this 1 became 0, and everything else was left unmodified. Okay, but does this work for the second case, right? Where the bits are the same? So let's try that. We put a 1 in both locations, and then we try to XOR them with 1s in the corresponding locations, and both of them become a 0 because this flips the bits there. So this is problematic, right? It actually only works if the bits are different, because this will just always flip the 2 bits there. But this is actually not a problem, because what we need to recall is that in the case where the bits are the same, then we don't actually have any work to do. So we can come up with an algorithm based on this that basically checks if the 2 bits are the same or not. So let's go and give a high-level idea before we sit down and code it. Okay? So high-level idea, step 1 is to get the bits at A and B, remembering that it's 1 indexed. Okay, so in this case, it's 1 and 0. Second step, if these 2 bits are identical, we need to stop, because there's no point in iterating through the algorithm. There's no point. What we'll do in the later steps will mess it up, so we can just return immediately. Otherwise, we need to shift 1s into the correct spots. Okay, so here is 1. It's probably simplest to break this down into 2 numbers. So we have 1 with a 1 here and another 1 with 1. And then in the last step, we need to XOR them. So XORing this gives us the desired result. Okay. Maybe I should clarify what I mean by XOR them. So we XOR the second number, these 2 numbers together, and then these 2 numbers together, and that will give us the desired result. Okay. So with that detail, let's now go ahead and try to code this up. Okay, so let's go ahead and code up the algorithm now. So we need to go ahead and fulfill step 1, which is to get the bits at the corresponding locations A and B. Okay, so how do we do this? For simplicity, I'm going to first compute the indices of the bits, because these are 1 indexed, but really we in computer science generally 0 index things. It's just a little complexity in the program. So we just go ahead and offset the bit by the index by 1, okay, just to make it 0 indexed, because that's how bits actually work. Okay, and so now we need to get to the first and second bit. So int bit 1 is equal to, okay, how do we get the bit at a specific location? This is a very common technique, so if you haven't seen this before or forgotten it, make sure to maybe even pause the video, take some time to think about it, because it's a very important technique for bit manipulation. So I'll give you a moment to think about that. Okay, here's how you do it. You shift the whole number over by the desired index. So in this case, for the first bit, it's 1, and then you AND it with 1. Okay, and we do the same thing. second one. I'll explain it in a moment. So how does this work? So let's suppose that we want the pth bit, okay? So we need to shift the number, we want to shift the number over so that the desired bit is in the rightmost location, okay? So if it's a 0 bit, we shift it over by 0, which doesn't do anything. If we want the second bit, we shift it over by 2, so that the second bit is now in the 0th position. And then we end it with 1. Okay, so 1, the binary representation is a bunch of zeros, and then in its rightmost position, a 1, okay? So notice how that zeroes out all of the indices that are not the rightmost bit, okay? Zeros them all out, so they're irrelevant. And then if there is a 0 in the rightmost bit, that becomes that's still going to be 0 because of the AND operator. And if it's a 1, then 1 and 1 becomes a 1, okay? So in other words, the number that is now stored inside bit 1 represents the pth bit, whatever it was. Okay, cool. So that's step 1. And now we need to do step 2, which is basically determining if we actually need to do anything, okay? So for this, all we do is we compare bits 1 and 2, okay? And you may notice that I'm checking actually if they're not equal rather than they're equal. The reason I do non-equal is because we actually had hard-coded into the solution a return num here. So if they're not equal, then we can just skip whatever the XORing part and just move on immediately. Okay, we can just return num because there's no changes we need to make. But otherwise, we do need to make some changes. Okay, so let's recall the proposed change was to XOR it with 2 numbers. One of them has a 1 in the pth location and 0s elsewhere, and the other one has a 0 has a 1 in the qth location and 0s everywhere else. Okay, so how do we do this? So we go num equals num XOR, and we need to calculate such a number. But this is just going to be 1 left shifted by p, and likewise num equals num XOR 1 left shifted by q. Right? Because as we discussed before, this whole concept of shifting, we just move the 1 over p bits. So if it was, for example, the 0th index, then we don't move it at all. And otherwise we, move it however many. Like if it's a second, we're going to move it 2 over, etc., etc. Okay. So yeah. So that will shift the 1s over to corresponding locations. And then as we discussed in the slide demonstration, that this will lead to the correct output. So yeah, so there we go. So that is how we actually code up this question. So this is the solution. It actually isn't like the most complicated thing, although it was a bit of a journey to get to the maybe high-level approach. So yeah, so I hope that this was helpful. And yeah, best of luck on your future adventures with bit manipulations. Bye-bye, everyone.